Welcome to Pavinar's Webinars for the Pavement Community. My name is Andrew Bram, and today we'll be talking about writing an abstract. So why are abstracts so important? Well, the majority of readers of any journal article only read the abstract and perhaps the conclusion. Another reason to write good abstracts is most of our online search databases only contain abstracts. Now, while abstracts is kind of an academic name of a summary of an article, you can use this same format for other types of abstracts, which includes executive summaries and cover letters. Here is an example of a summary found in TRID database, and this is the abstract of the paper, R-Curves Characterization Analysis for Asphalt Concrete. So if you perform a TRID search and click on, for example, R-Curves, this will be the first thing that pops up, the abstract. So you want to make sure it is well written, and you want to make sure that the abstract sells your work, because immediately under this abstract is a link to a URL to the full paper. And so after people read this abstract, you want them looking for more. And after they click on that URL, they go to the journal paper webpage. And you can see here again, the abstract is prominently shown, but this gets people to the journal article, so perhaps they continue reading the journal article. So what makes an abstract good? Well, first of all, an abstract needs to have a strong motivation at the beginning. It also needs to then go into the problem statement or objective and outline the approach clearly but concisely. Finally, you do need to have some results, some quantifications, and the conclusions of your research. The length of each section is based on the abstract word limit. Some abstracts have no word limit, some are 500, some 300, and the hardest to write are the 100 word abstract limits. But in order to practice these different sections, you must practice not only reading, but also writing abstracts. So I encourage you to take a couple of abstracts and go through the exercises that we'll go through during this brief presentation so you can begin thinking about the different sections of abstracts. Let's break this down a bit though and provide a little more detail behind these 5 bullet points above: the motivation, the problem statement and objective, the approach, the results, and the conclusions. The motivation section should include information about what is known about the subject, and often more importantly, what is not known, and therefore why is the research necessary. So this will set the stage nicely for why you did this research. The problem statement and objective should answer the questions: what problem are you trying to solve, or what gap are you trying to fill? And this should be one sentence long, it should be crystal clear, and it should be high impact. Do not shy away from saying the objective of this research was, or the problem this research was solving is. Be crystal clear in that one sentence so people know exactly what the objective is. Now in the approach section, you want to have your methods and materials. So what was done, how was it done, and you want to focus on unique and innovative techniques. If you're doing an approach section and you're writing about, for example, asphalt concrete, you don't want to talk about bulk specific gravity because everyone knows how to run bulk specific gravity, or at least it's easy to find. So you want to focus on the innovative and unique techniques of your research and the approach found there. In the results, you want to answer the question, what is the answer? But you want to avoid qualitative words and vague words like very, small, and significant. And you want to use quantifications and key findings. So put some hard numbers into the results. And this should be the longest part of the abstract. Finally, the conclusion section, you should have your primary take-home message and include any additional findings of importance. Perhaps you could also include some potential impact and future recommendations as well. So those are the 5 sections. I do want to briefly go over some other notes. It is very uncommon to have citations in abstracts, so you don't cite other paper or other work in abstracts. You don't want to have any routine portions of the research, like I mentioned above. You don't need to put in information about the air content if you're working with Portland cement concrete. You want to avoid any sort of statistical methods and software details. Now, obviously, if you are writing a paper about statistical methods or about a specific software, and that is the focus of the research, you're going to need details. But if you simply run a t-test paired analysis for your data set, you don't need to get into details about that. You could just simply state based on the t-test, this is the result, because that's a very common statistical method. Now, in the paper, you want to talk about it a little more, but not in the abstract. And then finally, you should tailor it to the audience. Who reads the journal that you're submitting to? And you want to make sure that you are writing toward that audience. So let's practice some reading and writing, and let's go over one example. Now, this is the abstract that we saw in the first couple slides. I don't expect you to read this. We're going to break it down. But what I did is I highlighted each section so you can see the 5 sections here. And this is what I believe each section represented in those 5 bullet points in the motivation, the problem statement, the approach, the results, and the conclusions. So let's go over each one of these sections by themselves. So the motivation section, I'm going to read the bottom part and then we'll go over each question. Fracture tests, especially at lower testing temperatures, have become quite popular in quantifying low temperature cracking. However, current fracture testing analysis methods often use a single number, such as fracture energy or fracture toughness, to quantify cracking resistance. These tests do not capture both the initiation and the propagation of the crack. The resistance curve, or R curve, is widely applied in many fields, such as metal, polymer, and composites. The R curve considers cracking resistance as a function of crack extension, which includes initiation and propagation. So as we go through here, this research is on asphalt concrete, low temperature cracking, fracture testing, and it is talking about the R curve or the resistance curve analysis. So we do a pretty good job here of talking about what is known about the subject. We also talk about how what is not known about the subject, about how the tests do not capture both the initiation and propagation of the crack. And we talk about sort of why the research is necessary. We kind of repeat this initiation and propagation concept, but I don't think that we did quite as good of a job at talking about why the research is necessary versus what is known and what is not known about the subject. So the problem statement of the objective, this is actually a part of the previous paragraph. These tests do not capture both the initiation and propagation of the crack. I think we do a pretty good job of talking about what problem you're solving. We're obviously talking about the initiation and propagation. I think we do an okay job at doing the gap that we're trying to fill. That's kind of set up by the motivation, but these type of things are a little bit subjective. It is one sentence, it is clear, but I don't think personally it's high impact. We should have said the objective of this research is to quantify the cracking of asphalt concrete to capture both the initiation and propagation, or something along those lines. So while it's kind of clear, it certainly isn't a high impact. And the fact that it's embedded in the middle of the motivation section does not help. So it looks like there's a little bit of work that Dr. Young and I could have done here. Now here's the approach section. In this research, 3 asphalt concrete mixtures, including hot mix asphalt with reclaimed asphalt pavement, and warm mix asphalt with wrap, were tested at 2 temperatures, 3 levels of aging, and 2 levels of moisture condition by the semicircular bend fracture test. R curves were constructed using the data from the fracture test, and digital images were utilized to capture the crack extension. In addition to capturing the traditional fracture energy, 2 new parameters were explored using the R curves. the cohesive energy, and the propagation parameter energy rate. So I personally believe this is a great approach section. We talk about the materials and the methods. We used 3 asphalt concrete mixtures. Some had wrap, some were warm mix. And then we talked about the semicircular bend fracture test. So we nailed that. I think we did a very good job on what was done and how it was done. We talked again about the semicircular bend test. We talked about digital images. We talked about taking R curves from the fracture test data. So I think we did a very good job of this. And then we also focused on unique and innovative techniques. We talked about these new parameters, the cohesive energy and the propagation parameter energy rate. So I think we did a very good job with this approach section. Now for the results, it was found that cohesive energy was always in a narrow range, approximately 500 to 1,000 joules per meter squared, compared to the fracture energy range, approximately 500 to 1,700 joules per square meter. Overall combinations of aging and moisture conditions, which indicates that the crack initiation may not be as sensitive to temperature, aging, and moisture as fracture energy. So we have some good answers. We talk explicitly about our cohesive energy and fracture energy results. We did an okay job with avoiding vague words. We did say, which indicates that crack initiation may not be as sensitive. I would say that's a vague statement. My definition of sensitive may be different than your definition of sensitive. We definitely used some quantifications and included some key findings. We list actual ranges of cohesive energy and fracture energy. This, however, is not the longest part of the abstract. The longest part of the abstract by far was the approach. So we did not do a good job of really focusing on the results and providing the biggest bang for our buck in the results section. Also, the motivation section, I believe, was longer than this. So I think there's a little bit of work we could have done there. Finally, the conclusions. The results of energy rate indicated that moisture and short-term aging impact the crack propagation by reducing the resistance of crack growth. These results proved that R curves are a potentially useful tool to quantify the cracking resistance of asphalt concrete in both crack initiation and propagation. So we have a pretty strong take-home message here. We talked about how R curves are a potentially useful tool, and we again reiterate the crack initiation and crack propagation. I think we do an okay job on any additional findings of performance. We really don't introduce anything new here, so we could have maybe done a little better with that. We do a good job of potential impact because we're talking about initiation and propagation, two things that we think are very important in cracking, and we have no future recommendations, so we did not do a pretty good job with that. And I believe that the word limit for this abstract was 300 words, so I think we definitely could have done a better job here with some future recommendations. So that was just one example, and obviously the opinions on how writing an abstract goes into the subjective category. So these are just my opinions on how to write a good motivation section, a good problem statement and objective section, a good approach, results, and conclusions sections. But I really encourage you to continue practice reading and writing. We went through one abstract together. Go through the same abstract again. Go through some abstracts you've written. That is an abstract that Dr. Yang and I wrote, and I still don't think it's perfect. So there's always room for improvement, and I encourage you to continue practice reading, practice writing abstracts, and perhaps even go through some structured exercises. And to finish with, this is an excellent exercise to do in a group as well, because if everyone reads the same abstract, I guarantee you they'll come up with different answers to those questions. And it's a really good way to see what other people think when they're reading papers. So thank you for joining me today. I appreciate it, and I hope that you learned a little bit about writing an abstract.